Today we will solve the integration which is frequently used in quantum mechanics problem solving, so that in future I can save a lot of time by explaining this standard integration. First, we will start with I am going to give few lectures on the integration frequently used in quantum mechanics. First, I will take integral between 0 to a, that is Fox width is a, x squared cos 2kx dx. Now you can see you can do this integration by parts. Let this be u and this is dv. So u is x squared, then du is 2x dx, and dv is cos 2kx. That means v is equal to minus sine 2kx over 2k. Now integral u dv is equal to uv minus v du. So here u is x squared and v is minus. So that minus I brought first. Sine 2kx over 2k, limit 0 to a. Then next VDU. V is minus, so minus VDU. Oh, V is here we have one minus, so minus into minus will become plus. Plus 2, uh, that is plus 2 integral between 0 to a. This 2 comes because of this fact. So 2x dx is du. So we can say 2x dx is equal to du. So u dv, uh, s- I, sorry, v du. V is minus sine 2kx over 2k. So we got it plus. Then du, I am replacing this by uh, 2x dx. So sine 2kx over 2k. We are integrating with respect to x. Now we will continue this process. Now we got this expression. First term you apply the limit. Of course, for 0 x is here, so it will be 0. Sin 0 also 0. You apply the upper limit. What will happen if you apply upper limit? 2kx. 2k is n by a, then x. Now if x is equal to a, if you replace x by a, then AA will get cancelled. You will get sine 2n pi. That also 0. So this entire terms will become 0. Then you take only this integral part. That is 2 times integral between 0 to a x sine 2kx over 2k dx. Here this 2 and 2 will get cancelled. These two. So naturally you take 1 over k outside, 1 over k outside. Then integral 0 to a x sine 2k x dx. Now you apply this formula, integral by parts. Integral u dv is equal to uv minus vdu. Here you take this as u and this as dv. So u is equal to x, then du is equal to dx. Then here dv is sine 2kx, then naturally v is equal to cos 2kx over 2k. Now you substitute this value here. So this is the integral between uh, 0 to this integral. This integral 0 to a x squared cos 2kx dx is equal to this 1 over k is there, 1 over k. Then uv, u is x, v is equal to cos 2kx over 2k. We limit 0 to a. Then next minus 1 over 2k squared 2k squared cos 2kx dx. So now we got this expression. Now we will apply the limit path. Now we got this expression. Here you take care of this integral. What is the value of this integral? This integral, if you integrate it, you will get sine 2kx over 2k. Uh, but sine 0 also 0, sine a also 0. If you apply for upper and lower limit, this will be 0. So you can ignore this. Then you come to the first term. First term is 1 over k. Of course, you have. If for lower limit, it will be 0. What will happen to upper limit? Upper limit, that 2kx. Uh, Now I can write 2k. K is n by over a. X is a. So a will get cancelled. Then this will be 2n pi. So even number of pi. Naturally, this will be plus 1. So 1 and you have x here. So a multiplied by 1 a. So already here k is there. You bring 2k also outside, then this will be a over 2k squared. This is the standard result which we are going to use frequently in quantum mechanics. Thank you very much for watching my video and supporting me continuously. Thank you very much.